Hey there, I'm Nix, and I have another video where I solve the problem for the Getting Started Easily on LeetCode playlist. As always, I'll go through the entire process of solving the problem, giving you all the details, through the planning of the algorithm, to the coding of it, to the analysis of its time and space complexities, and looking at LeetCode rankings. If that sounds interesting to you, then stay tuned. Welcome back. I've already sorted the gigantic list of problems that LeetCode has via acceptance percentage. So let's just scroll down and see the next thing to do, which is, last time was the running sum of 1D array. This time, defanging an IP address is up. For this problem, we are going to be given a valid IPv4 IP address, and we want to return a defanged version of this IP address. And then it explains what a defanged IP address is. Instead of the period that is present, we replace it with a period inside of brackets. So this input address is going to be transformed into this address. And the only constraint that we're given is it is a valid IPv4 address. Now, the thing that immediately pops into my mind is, well, if I want to return the defanged version, let me carve out some memory and create a new string that will house that defanged version. Then what I'll need to do is go through our given address, and every time I see something that isn't a period, well, I can just append that directly to the new defanged version. But if I do find a period, then I want to append the two brackets and a period inside of them instead of just the period itself. And as soon as I get through the loop, I can simply return that defanged address and the problem should be complete. So let's go and look at that code. First up, I need my defanged address string, which I just set to be empty at this point. Here's the basic structure of the for loop. I'm using a ranged for as opposed to the default version that uses I. Does the exact same thing, and this is really good for going through every item in a particular container. So for this one, I want to go through and look at every letter, which has the auto type, which essentially tells the compiler, you figure out the type, I don't want to bother doing it. I could have also just outright said this is a character type, but either work. But for each letter in the address, I want to do stuff. And the stuff I'm going to do is going to be encased within an if-else statement. What I want to see is if the letter is not equal to a period, I'm going to do stuff. Otherwise, aka if the letter is a period, I want to do a different set of stuff. That stuff being these two lines here. So if I find something that isn't a period, well, I can simply push back that letter and add it to the defanged address string. Otherwise, I've found a period, and thus I want to append this string to it. Finally, this method expects to have a string returned, so we need to return that defanged address. And with that last line of code, this should correctly defang an IP address. So let's start clicking buttons and seeing if I messed everything up. And we get an accepted here. Excellent! You see every period is correctly replaced by what we want. So let's hit the big submit button, and I am judged successfully. Before we click on the text to see the graph layout, although you can see a bit of the rankings here, let's go through and see what the time and space complexities would be for this real quick. Space complexity is going to be dependent on this string that we used. It has variable memory usage that is dependent on the address. It's going to be a little more than that since the defanged address is going to be a larger string than the normal one. But in terms of big O, it's still going to be linear, and it's still going to be dependent on that string size. So this one would still be a big O of n space complexity. For time complexity, we need to look at the for loop. It's going through the entire address and doing some things. Again, with pushback and appends, they do have amortized time to them, so it makes it a little bit more complicated. But for argument's sake, let's just go with the amortized constant time and assume that they're constant. And really, for an IP address that is so small, it's not really going to matter too much in the long term. If you're defanging an address as part of a larger piece of code, this is not where your bottleneck is going to be. So, let's just go through and assume that amortized constant is in fact constant, which means that this for loop is essentially going to depend on, again, the size of the address. So it's also going to have kind of an amortized big O of n time as well. So big O of n for space, big O of n for time. Last thing to do is click on the text here, and we see not much of a distribution here, which again, the IP address is a very small string. You really can't differentiate too much in terms of various types of solutions. And this version, what was the thing, 6 megabytes? Yeah. So it kind of went off of the graph here. I've seen it show up somewhere around these areas as well. Now the final thing that you might be wondering is, hey, you have another solution here. I showed you this solution, but what was this one? This one was just another way to go about it, but again, there's not too much of a reason to play around with this. As I said, if you need to defang an IP address as part of a larger piece of code, this is not where your bottleneck is going to be, but I did do it another way. If you want to try your hand at figuring out what this solution is, then I'll pose a question for you. How would you solve this problem without using pushback or append? And I'll give you a little hint. Think of string concatenation and a reverse for loop. So with that challenge posed to you, I guess, that was how to solve the defanging an IP address problem on the LeetCode website. I hope this video helped you out. If it did, consider subscribing. And as always, I will wish you happy coding and to have a nice day.